Okay. So previously I explained functions and stuff, and I've went through most of the core basics of Python already. I mentioned that I was going to teach you classes. I'm not actually going to go super in depth about like syntax and how to use classes, but I just want to give you like an overhead idea of how classes work. Because when we work with the Vex library, we're actually using classes in the background. Like motor is actually a class, and we actually make an instance of the motor class when we use a motor or define, let's say, the left motor, right? And of course, I mentioned Vex library, so I'll also briefly go over what a library is. So first, let's start with what classes are. So I'm going to use an example of a basketball, okay? So we have this thing called a basketball, right? Now, a basketball can come in any color. It could be from any brand. It could have different specifications, including sizes, the amount of PSI you have to inflate it to, the color, and whatnot, right? Now, let's say I have a green basketball from some off brand company, and that can hold more air. So it has, I guess, a lower PSI. I don't know. And then we also have an orange basketball, which is the official brand, the official ball. It's orange, of course, and it's extra bouncy. I don't know why it's bouncy, but maybe it just has a different material. Okay. Now, ultimately, we can still throw any type of basketball, regardless of color or bounciness or whether it's off brand. You can still throw the basketball. And it doesn't even matter how you throw it. At the end of the day, you're still going to have to do the same wrist flick or whatever, same um, way of throwing essentially. The difference comes when we have to, for example, dribble the ball. Because one of the balls is more bouncy, we might have to dribble it a little bit faster than the other one. But at the end of the day, we're still throwing the ball down and then catching it and then throwing it, and that's kind of what dribbling is, right? Ultimately, the actions in dribbling are the same. It's just slightly altered based off the specifications that we give it. And then there's also inflating. You still inflate both balls, like when it runs out of air, but for example, the one that holds more air, you might need to inflate it to a lower PSI versus the one that is extra bouncy might be bouncy because it has a higher PSI. So ultimately, you're still using the same pump to inflate it, and you're still pressing the same buttons. You're still pumping the pump the same way. It's just the amount that you pump it to will differ a little bit. So it's just a small difference between the two based off the specifications of the basketball. So what I mean to say is methods are something that you can do in general, the actions you can do to any type of basketball. Basketball is a class, and the green basketball, an orange basketball, another type of basketball, those are all instances of basketballs. Those are all versions of a basketball. Ultimately, they're the same type of ball, a basketball. Now, the specifications are actually referred to as attributes. So the instance green BB, as I mentioned here, green basketball is green, off brand, and holds more air. And then similarly for the orange basketball, it has the other attributes. And again, as I mentioned, they use the same methods. It's just the ultimate result of how the method will have an outcome might slightly differ between the two because again the attributes that we give it are going to differ based on the instance. Now something to keep in mind is even if I throw the green basketball, nothing would happen to my orange one, right? The instances are independent of each other. They're not reliant on each other. Like if I do something to the green basketball, nothing will happen to my orange one. Unlike that, though, if we do something at the class level, if we change fundamentally how a basketball is defined or what you can do with a basketball, then both of the instances of basketballs, both the green and the orange basketball, despite them having different specifications, are still basketballs, will have some change depending on what we changed in the class level basketball. Now, that's what a class is, right? It has methods, it has instances, and instances have their attributes. Now, we have one class called basketball, right? Now, let's say we had another class called basketball player, and we had another class that had basketball court. And each of those would have their own methods, their own instances, or you can make an instance of a basketball court with its own attributes and etc. You can do those different things with these different classes. But since they're all related to playing a basketball game, whoever's trying to play a basketball game is going to need all of them. And so rather than individually calling each of them, they just import this basketball game library, which essentially gets all of these classes in like one package. Package is another term interchangeably used with library. And yeah, the advantage of using libraries is that it doesn't necessarily have to be your own code. You don't necessarily have to have written the class basketball. Someone else could have defined what a basketball is, and all you have to do is make an instance of the basketball and use the predefined methods, which already had code in them. And you can do that for any of the classes in this library. So similarly, in Vex, we have classes like the class motor and the class vision sensor and the class three-wire port, which is the pneumatics, and all those different types of classes. And essentially what we do is we make an instance of the motor and we call it the left motor. And we use the methods of motor such as spin, such as spin. And the parameters we give, so kind of like how functions work, we give it parameters, which is the direction. So when we make the instance of motor, we might have to give it some attributes that say, in what orientation is the motor placed on the robot? It might be placed upside down, which means when we say spin, we're going to actually mean the opposite of the direction that we say because it's upside down. So yeah, we give it different attributes such as in what port of the brain is it located in, and in what type of gear ratio does it have, what kind of gear cartridge is it using, right? Those are the different attributes that we give it. And ultimately spinning will still spin the motor, it's just the instructions you'll have to give to the motor might be slightly different. So yeah, that's essentially what the classes and the libraries are. Next, I'll show you actually using Python in with the Vex library in the next video, so for motors and stuff. Yeah.